Okay, so in this video you are going to learn about the various effects of heat. So now when we heat any substance, what happens? It creates some changes. So it changes the substance in many ways. So what are the different ways in which heat changes substances? Can you think of them? Okay, let us see. The first main thing that will happen when you start heating a substance is the physical state of the substance will start changing. Think of some examples. The most common example is ice. If you start with water in its solid state, that is ice, then and if you start heating it, it changes to liquid state. It becomes water. So it melts. Ice melts and becomes water, changes to liquid state. Then when you continue heating it further, it changes to gaseous state, right? So that process is called vaporization, and so we'll get back to this in detail later. Now we'll just quickly summarize. I'll just give you an overview of what we are going to cover in today's class. So you will learn that the physical state changes when a substance is heated. Then what else happens? Temperature also changes. If you heat a substance, temperature increases. If you cool it down, temperature will decrease. The other main thing that will happen is the chemical structure will change. For example, when something burns, it reacts with other the molecules react with each other, giving you a new compound. So the chemical structure of the substance changes. Then the other change in size. So if most substances, they become larger when they are heated and become smaller when they are cooled. So these are the main changes that happen as a result of heating or cooling. So in this lesson you will be learning about these changes in detail, and when we look at the changes in physical state, you will learn some definitions and some experiments. So what are the definitions you will learn? You will learn about the definition of melting or freezing point, boiling point, and what is ebullition. Then you will learn an experiment which will demonstrate that melting point is same as freezing point for any given substance. And using that same experiment, you can also find out or measure the melting point of wax. Okay. Then to demonstrate that the size of substances increases on heating, you will learn learn to do many experiments, actually 5 experiments. So in the first two experiments, you will see we will demonstrate how solids expand or contract on heating or cooling. In the third experiment, you will come to know that different substances expand at different rates. So using a bimetallic strip, you will prove that. Then in the fourth experiment, you will see that liquids also expand on heating and contract on cooling. And finally, in this fifth experiment, you will see that gases expand on cooling and expand on heating and contract on cooling. And you will also know that you will also learn that when the size increases, what is the change in density of the substance. So a change in size of the substance causes a change in density. You will see why. Okay, so now let's get started. So before you learn about any topic in physics, you should know why we need to learn that. What are the applications of that, right? So what is the real life application of that? So let's see that. Okay. Now look at this picture. Okay, this is a picture of the Dal Lake in Kashmir. So what do you see in this picture? you see snow covered mountains, you see this lake, and you see lot of clouds. Okay, now this scene actually is a very rare scene where you can see water in all the three states in the same picture. So you see water in liquid state in the lake, you see water in the form of solid state in the snow, and you see water in the form of vapor or gaseous state in the clouds. That is, the water from the lake evaporates, rises up at that great height, it cools, so it condenses to liquid state, and then it those water droplets in the clouds, they freeze and they fall as snowfall on the mountains, which again due to the heat from the sun rays melts and becomes liquid, and again due to the heat from the sun the liquid water evaporates. So this is the water cycle, and this whole water cycle is an effect of heat. So now do you see how heat is such an important phenomenon, that is it has such important effects. So you can understand things around you if you understand the effects of heat. Okay, now what do you see in this picture? These are actually steel pipelines carrying petroleum across a desert. So now why do you think they have built the steel pipelines in this kind of strange curved loops? They will end up using lot more steel than necessary, don't you think so? Because no, common sense tells us that we should build a steel pipeline in a straight path, in the shortest distance between 2 points is a straight line. So why do you want to unnecessarily consume more steel and build it in such huge loops like this? So again it is due to the effect of heat on substances, namely the steel pipes. So the desert becomes very hot during the day, and because of that the pipes will become very hot, and when they become very hot, what happens? These steel pipelines will expand, and if it is just built like one single straight pipe, if they expand, then they will break at the ends, isn't it? Or they will crumple. So to avoid that, you build it in such sections, small sections of pipes. So each of these sections will expand, and because of that the size of the loop itself becomes large. Let me demonstrate it here. So if you have like this, so if each of these segments of pipes become longer, what will happen? The size of the entire loop becomes longer, like this. Okay, is it clear? So if it had been a straight line, just a straight line pipe, then it will just at the ends it will break. Okay, because it's going to expand, and at these ends, since it has no space to expand, it will break. So it will start crumpling in these regions. Okay, so to avoid that only we build the pipe in so many small segments, which if they expand, the entire loop will rise up above the ground. Okay, so do you see how the effects of heat play an important role even in transporting petroleum across the deserts? Okay, okay, so now these are the objectives of this lesson. So you will be describing, you at the end of this lesson you will be able to describe the effects of heat, then you will be able to define so many things and so many experiments, and finally what is the concept of density. Okay, so now let's look at this diagram in detail. The first change caused by heat is changes in state. So as you go up in this chart, you find that the energy is being provided to the substance, heat energy is being added to the substance. Okay, so the direction up, so the position of the state indicates the higher it is, the more heat energy is present inside it. So the plasma state has the maximum heat energy stored in it. So the changes of state which happen are given by the arrows. So on heating liquid, it vaporizes to become gas. On heating gas, it gets ionized and becomes plasma. If you cool the plasma, it will again become neutral particles, so it's called deionization, it becomes gas. If you cool the gas, it will condense to form liquid. If you cool the liquid, it will freeze to form solid. If you heat the solid at low pressures, it will directly convert to gas, and that is called sublimation. If you condense the gas at high pressure, it will directly deposit as solid particles. Okay, or is it low pressure? Not so sure, but it's dependent on the pressure whether the gas will directly change to liquid or solid state. Okay, fine. Then the next change is change in temperature, right? So for that we can easily demonstrate that if you take a beaker of water, so you just take a beaker of water and fill it with and place a thermometer in it. Okay, so and you start heating it. Okay, so when you start heating the thermometer, beaker of water, the temperature reading in the thermometer will start increasing. So that is a proof that if you heat a substance, the temperature increases. Then the next change is change in chemical structure. For that, the example of an omelette can be used. So the yolk inside the egg is in the form of liquid state, but when you make an omelette, that liquid egg yolk becomes solid, isn't it? So that is because the protein gets denatured in the egg. So that is an example of change in chemical structure due to heating. Now to demonstrate the change in size, that example of steel pipeline is, you can think of that. So you can also see it for yourself when you perform these experiments. So let us see the first experiment, which consists of heating a metal rod. So let me explain the setup of that experiment. So now we are going to do this particular experiment. Okay, so what we do in this is, we take a metal rod, attach it to a stand, and then we will heat it using spirit lamps. Okay, we will use 3 spirit lamps. So when we start heating it like this, the metal rod will expand, it will become longer, but this expansion is very less. So how do we measure this expansion? So for that we use a special pointer which consists of a circular scale like this. So you will have a circular scale, okay, that is the scale. and this is the pointer. Okay, like this. So when this rod expands, it will strike this pointer, and because of that this pointer will start, it will turn in this direction. Okay, so even though the length of the expansion of the rod is very less, the angle by which the pointer will rotate will be more because of this lever effect. So you can easily detect the expansion in the rod due to heating, and when you remove the lamps it will start cooling, and again this pointer will get back to the original position. So that is the proof that if you cool an object it will start contracting. Okay, so that is the first experiment. Now we'll move on to the second experiment. So this second experiment is also to demonstrate that solids expand, but this time we will use a different setup. What we will do is we will take a ring, it's called a spherical ball and ring apparatus. So it consists of a ring, and you will drop a spherical ball whose diameter is exactly matching the size of the ring. Okay, so it will just be able to pass through this ring. So then what you will do, you will take this metal ball and you will heat it. So when you heat it, it expands, and now if you try to drop it through this ring, it will not be able to pass through. So again you wait and cool it. So after you cool the ring, and again when you drop it, cool the metal ball and again drop it through this ring, this time the metal ball will again pass through because it has shrunk after cooling. So this is another proof. Okay, then the third experiment is to show that different metals expand at different rates. So for that we use something called as a bimetallic strip. It consists of two strips made of copper and iron. Okay, so it will be something like this. So this is the copper part. Okay, here this is the copper part of the bimetallic strip. Now let me draw the iron part of the bimetallic strip. Yeah, this is the iron part of the bimetallic strip. Now copper expands at a greater rate than iron for the same increase in temperature. So when you heat this bimetallic strip, say I put a Bunsen burner and heat it below the bimetallic strip and heat it. So what will happen is, at different speeds, at different rates, so the copper part will become longer and the iron part will not expand so much, so it will not be able to keep up with it. So because of that, but since these two strips are joined together, it has no choice but to bend towards the iron side. So you will find that soon the bimetallic strip bends. So now if you took both the strips of same metal, say both iron or both copper, then what will happen? Then both will expand at the same rate and the whole bimetallic strip will become longer. So there won't be any bending. Okay, fine. Now to prove that liquids expand on heating, the experimental setup is very interesting. We'll be using a test tube. Okay, so you will start with a test tube like this, and you will fill it with water. Okay, so fill it to the brim with water, then close it with a one-hole rubber stopper. Okay, so it has a hole and you close it with that one-hole rubber stop. Okay, then what you do, you insert a capillary tube through that hole. So let me draw the capillary tube. So when you insert it through this hole, what will happen? The glass of the capillary tube occupies some volume. So when you push it in through this rubber stopper, some of the water will rush up through the capillary tube. So the water level in the capillary tube will now increase. Okay, so let us say it has now increased to till this much height. Okay, so now what you do is, with a marker pen, mark that level of the water level. So let us mark it like this. Okay, now you start heating the test tube using a Bunsen burner. So now the water will start expanding, and since you have used this capillary, even though the volume of the water in the test tube expands very little, the volume inside the capillary tube is so less that for a slight increase in volume, the change in height of the capillary tube is very large. So the water level will start increasing very rapidly inside the capillary tube like this. So if you keep heating, it will come out of the capillary tube also. Now if you remove the Bunsen burner, again the water level will start going down. Okay, so this is proof that water also expands on heating and contracts on cooling. The next experiment is very similar, that is to show that gases expand on heating and contract on cooling. Can you now guess how the setup will be? It's very similar to this. Only difference is, instead of filling the test tube with water, you will fill it with air. And since it's already filled with air, you don't have to fill anything actually. You just close the glass tube with the rubber stopper and insert. Before inserting the capillary tube, you dip it in a beaker of water. Okay, so when you dip the capillary tube in a beaker of water, what will happen is, due to the capillary effect, a drop of water will stay stuck inside the capillary tube in the lower edge of the capillary tube, and when you insert it into this rubber stopper, then that drop of water will rise up like this. Let me draw it quickly. So if this is the capillary tube, now what will happen is, this drop of water will be somewhere here. So now again using a marker pen, mark that position. Now you start heating. Inside the test tube it is now empty. Okay, there is no water inside the test tube, only air. Okay, so now when you start heating it, the air inside the test tube will expand and it will push the water droplet up through the capillary tube. So the new position of the water droplet will be above this mark which you made with the marker pen. So that is the proof that water expands on heating. And when you remove the Bunsen burner, then it will again start cooling and the water droplet will come back to its original position here. So it is a proof that water also contracts on cooling. So now what else is left in our lesson plan? So we have finished all the 5 experiments. Now because of an increase in size, density should decrease. Why? Because density is defined as mass by volume. See, density is equal to mass by volume, and mass of the substance is not going to change when you heat or cool it, so it's a constant. So you have mass is equal to density into volume. So now if the volume is going to increase and the product has to remain constant, then obviously density has to decrease. And similarly, if volume has to decrease and the product has to remain constant, then density has to increase. So that's why density also changes on heating, because volume changes on heating. Okay, so then we have covered everything so far. Let us see what are the definitions. So melting or freezing point is the temperature at which a substance changes from solid to liquid state or liquid to solid state. So that experiment I have to cover, right? Okay, so melting point of wax. So let's see how to do that experiment. So in this experiment what you will do is, you will take a beaker of water, in that you will place a test tube filled with wax. Not completely, you will put a little bit of wax in the test tube. So you will put a little bit, okay. Here. So these are the pieces of wax, and I am going to close the glass tube, test tube with a rubber stopper, 1-hole rubber stopper. This is that, and I will insert a thermometer into the wax so that I can measure the temperature of the wax. So thermometer will be in, say, yellow color. Okay, that's the thermometer. Okay, and I start heating the water using a Bunsen burner. So I start heating the beaker using a Bunsen burner. Of course this beaker will not be heated directly, it will be placed on a tripod stand. So on this tripod stand I will have a wire gauge. Okay, so now as the water gets heated up, it's the temperature of the wax also will increase. So at 45 degrees it will start melting. Now while it is melting, the temperature does not change at all, it remains constant at 45 degrees. Once the entire wax has melted completely and become liquid state, then the temperature starts increasing again. So you let it heat till say 50-55 degrees, then you remove the burner, so it will start cooling. So once it reaches 45 degrees, then it starts to solidify again. So that means now it is freezing. So as long as all the wax has not melted, has not solidified, the temperature will remain constant at 45 degrees. So this is the proof that melting point is same as freezing point for any substance, and for wax this temperature is 45 degrees Celsius. So after everything, after all the wax has solidified, again now the temperature will start decreasing. So this is the experiment. Okay. So now boiling point is the temperature, constant temperature at which a substance changes from liquid to gas state, and ebullition is this process. Okay, so ebullition is just another name for boiling. So we have covered this experiment also, so that completes this chapter. Hope you enjoyed the lesson.